Good learners, welcome back to our mathematics class. In today's class, we are going to start with the topic circle geometry, that is, circle theory. This class is going to be a series of classes in which I want you to follow the class step by step. If you are a new member on this channel, just coming across our channel, kindly subscribe to my channel and click the notification bell for my subsequent contents. And do not forget to share, like, and comment as we move on. Now, this topic is talking about circle authoring. When we have a circle this way, this circle has some characteristics. One of the characteristics is it has a center. It has a center. Since it has a center, the distance from this center to any part on this line is referred to as the radius. Why this line? When we fix this line doesn't have the starting nor the end. Okay, let us fix any place. Let me fix this place as point A. So if you move from this point A back to this point A, this line where we are moving across is what we call circumference. It's called a circumference. So the distance from the center of this circle from any part of this circumference is called a radius. Now, when you extend the radius to touch the other part of the circumference, we call it the diameter. We call it the diameter, which means that a diameter is equal to 2 multiplied by a radius. Diameter is 2 times radius. While radius equals to diameter over 2. So diameter is 2 multiplied by radius, while our radius is diameter over 2. Fine. Let us consider another circle this way. But in this time, we are having a line that is dividing this circle into two different parts. This line dividing this circle into two different parts, the line is referred to as a chord. As a chord. This is dividing this chord into what we call a minor segment. This is a segment. But this segment is called minor segment, while this upper segment is called major segment. So, when we have a line dividing a circle into two different parts, that line is called a chord, while it's dividing that circle into the minor segments and the major segments. So with these characteristics of circle, we are now going to be looking at the theorem in this circle geometry. Today we are going to deal with the first theorem. So let's move on. Theorem 1. This theorem can be called any number. Maybe theorem 1 in some textbook, theorem 10 in some textbook. Let me call it theorem 1 as we move on. The theorem states a straight line drawn from the center of a circle to bisect a chord, which is not a diameter, is at right angles to the chord. When we have a circle this way, our circle, and we are told that a straight line drawn from the center of a circle to bisect a chord. Let's assume this is our chord. A, B is our chord on the circumference. There is a straight line drawn from the center of this circle. A straight line is being drawn from the center of the circle to bisect a chord. The word bisect means to divide the chord into two equal parts. And this chord is not a diameter. This straight line that is bisecting this chord is at right angles to the chord. Meaning that when we have a vertical line by setting an horizontal line, it forms angle 90 degrees. So this is what we refer to as a theorem. Now, if you now complete this chord, you can see completing it this way, it forms a right angle triangle. So if you call this point O, call this point O, from here you can work out the radius using your Pythagoras theorem and taking out any of this triangle that is here. This angle OAB. Let's say, so here you can get your line OA through Pythagoras theorem. OA square is going to be equals to line AB square plus line OB square. This is called Pythagoras theorem. You can check this in one of our classes by clicking the description below to go through the class on Pythagoras theorem, because we are going to make use of Pythagoras theorem in this theorem. So let's look at the first example in order to apply it with this theorem. Example 1. A chord of a circle is 12 cm long. The radius of the circle is 10 cm. Calculate the distance of the midpoint of the circle of the chord from the center of the circle. Now let's look at this. Given a circle this way, a chord of a circle is 12 cm long. Let me draw my chord this way, and let me call it AB. And this chord has a length of 12 cm. A length of 12 cm. Then the radius of the circle is 10 cm. We know radius means distance from the center to join any part of the circumference. So it's going to join either line A or line B, and it is 10 cm. If it is joining line B as well, it's still 10 cm, they equal. Calculate the distance of the midpoint of the chord from the center. This is from the center, distance from the center to meet the chord. So it's going to form cos 90 here. Now, we want to now look for the distance, which is this I. Let me call this point O. To check this one, let's call it small letter A. Now, taking out that particular triangle, small a, 10 cm. Then this line has divided this 12 cm into two. So we are going to have 6 cm here and 6 cm here. So this is 6 cm. Now I want to find the value of A. And don't forget I said you are going to make use of the Pythagoras theorem. According to the Pythagoras theorem, it states that the square of the hypotenuse side is equal to the square of the sum of the two opposite sides. And the first thing to identify our hypotenuse side, identify your box 90. This is your box 90. Any side facing the box 90 is your hypotenuse side, which means that we are going to have 10 square is equals to 6 square plus a square. The square of the hypotenuse side will equals to sum of the squares of the two opposite sides. 10 square means 100. That's 10 times 10. So 6 square means 36 plus a square. Fine. Let me take this one here. 100 minus 36 is equals to a square. 64 equals to a square. I need my a. I have to find the square root of both sides. Square cancels square roots. So a equals to 8 centimeters. So that is the value of the distance from the midpoint that cuts the chord. Example 2. Calculate the length of a chord of a circle of radius 26 centimeters if the chord is 10 centimeters from the center of the circle. Having our circle this way, calculate the length of a chord. Let me have my chord this way. This is my chord, x, y. Calculate the length of a chord of a circle of radius 26 centimeters. You know a radius means distance from the center. Let's say this is the center of the circle. The distance from the center of the circle to any part of the circumference So this distance is 26 centimeter. If the chord is 10 centimeter from the center of the circle, the chord is 10 centimeter from the center. So this is center. So distance here is 10 centimeter. Let me call it point O. So when we have a vertical and horizontal, we have a bus 90. And don't forget, we are asked to find the length of this chord. And you cannot find the whole length of the chord except you first of all find the length of, let's call this one point M. Length of M to Y. Any answer you get, you multiply it by 2 to get the whole length of X, Y. Taking out this triangle this way, we have O, we have M, and we have Y. So this is 10 centimeter. This is 26 centimeter. We are going to find this. Let me call it my X. And the first thing to identify your hypotenuse side. My hypotenuse is this 26 centimeter. Because this bus 90 is facing this side. So the side facing your bus 90 is your hypotenuse. So the square of the hypotenuse side, 26 square, is equals to sum of the squares of the two opposite sides, which is what? 10 square plus S squared. Now we have 26 squared. Let's multiply it. 676 equals to 100 plus S squared. Taking this one here, 676 minus 100 is equals to S squared. When you subtract this one, we have 576 is equals to S squared. So to get the value of X, you have to square root both sides. Let's square root both sides. Square cancels square roots. So square root of 576 gives 24, which is in centimeter. So this line MY is equal to 24 centimeter. But we are asked to find the whole length, which is line XY. So our line XY will now be equal to 2 multiplied by line MY. That is 2 multiplied by 24, which gives what? 48 centimeter. So the length of this chord is 48 centimeter. Don't forget to like this lesson, share, and also leave a review on it. So let's move on. Example 3. Two parallel chords lie on opposite sides of the center of a circle of radius 13 centimeter. Their lengths are 10 centimeter and 24 centimeter. That is the length of the chords. What is the distance between the chords? Having a circle this way, two parallel chords lie on opposite sides. We have two parallel chords, one here and the other here. Opposite sides of the center of a circle of radius 10 centimeter. This is the center of the circle. The radius is, let's say we have A here, B, X, and Y. Distance from here to here, we're told is 30 centimeter. Or distance from here from center to this point, we're told also is 13 centimeter. Fine. Their lengths are 10 centimeter and 24 centimeter long. The length here is 10 centimeter long, while the length here is 24 centimeter long. Now, what is the distance between the chords? Distance between the chords. This is one chord and the second chord, the distance between the chords. So, now we want to find, to get the distance between the chords, we must find the distance here, from here to this point, let's call it X. From this point O to this point, let's call this Y. If this point is M, let's call this N. So distance from A to B is 10 centimeter. Half of this is going to be 5 centimeter. 5 centimeter. And don't forget, when we have a vertical and horizontal, we have a plus 90 here. So since this one from here to here is 24, 24 divided by 2, we have 12 centimeter. and we have 12 centimeter. No, now to now get the value of x and y, we have to take out this right angle triangle separately. Now taking out the first one here, where we have 5 centimeter, here we have 13 centimeter, value of x. We want to find the value of x. The square of the hypotenuse side equals to sum of the squares of the two opposite sides. Hypotenuse is the side facing our bus 90. So we have 13 square is equals to 5 square plus s square. 13 square is 13 times 13. 169 is equals to 25 plus s square. Taking this one here, 169 minus 25 is equals to s square. When we subtract this one, we have what? 144 equals to s square. Let us square root both sides. Square cancel square roots. S equals to 12 centimeter. Meaning distance from N to O, line NO, equals to 12 centimeter. Fine. Now let us now take out the second triangle as well. Taking out the second triangle, here we have y, 12 centimeter, 13 centimeter. Now the hypotenuse side will still remain your 13. So it still remain your 13. So we have 13 square is equals to 12 square plus y square. 13 square is 169 equals to 12 square, 144, that is 12 times 12, plus y square. Taking this one here, we have 169 minus 144 is equals to y squared. When you subtract this, we are going to have 25 equals to y squared. So square root both sides, square cancel square roots, my y equals to 5 centimeter. And that y is line OM. Line OM is equals to 5 centimeter. But the question says, what is the distance between the chords? This is the first chord and the second chord. So the distance between the chords will be the addition of x and y. So distance between the chords, which is line NM, is the distance. So line NM will equals to, the answer we get here, line NO plus line OM. So line NO here is 12 centimeter, 12 centimeter plus line OM 5 centimeter. So when you add it up, we have what? 17 centimeter. So distance between the two chords is 17 centimeter. So if you are a new member on this channel and you've not subscribed, kindly subscribe to my channel and click the notification bell for my subsequent lessons. And don't forget to share, like, and comment so that other learners can also benefit from here. Thank you very much.